Hi, a good day to everyone, to my friends and my lecturer, Dr. Nofariza. My name is KHOO KAH Eng from BMMD section 1/2, and today I'm going to present about my assignment 1 regarding to the automotive component manufacturing. So as required in the assignment, the automotive component that I selected is the brake rotor, or as known as the disc rotor. So as the introduction, the rotor are the circular discs that are connected to each wheel, 2 in the front and 2 in the back. The rotors are designed to turn the motions or the kinetic energy into the thermal energy. As the calipers squeeze your brakes together, the rotor's large surface area creates frictions, and these frictions resist the spin of the wheel, which will eventually slow its rotations and movement of the car. So, for the types of the brake rotor, it has total of 4 types of the brake rotor that are usually or common used by the automotive industry. The first one is a blank smooth rotors, drill rotors, slotted rotors, and finally drill and slotted rotors. So next I will explain the material used for the manufacturing process. In earlier days, these brakes were made straight from the molten brittle ceramic materials, but the researchers have found that the short carbon fibers would be a solution for the brittleness of the ceramic. Hence, they used short carbon fibers, carbon powder, and heated molten resin as new materials for the manufacturing of the composite brake disc. So next I will be explaining about the manufacturing process of the brake rotors. So the following flowchart shows the basic or common manufacturing process of the brake rotors from the start to the end, starting by the mixing raw material, and the last is the inspection. So the first one is a mixing raw material. The short carbon fibers, carbon powder, and the heat molten resin are mixed together as foundation of the material for the next casting process. The mixture is poured into the permanent aluminium mold cavity, which is a shape in the brake disc, with automated machine until it is half full. Once it's half full, the mold is removed and the workers have to insert the aluminum cores into the belt with gaps around the mold that allows the cores to be inserted into the mold. This core will perform a ventilation cavity in the disc ring to prevent the disc from overheating. The mold moves back to the automated machine to fill the other half of the mold cavity with the rest of the mixture. Once the cavity is full, it is leveled using a roller and it is covered and pressed lightly to compact the content inside. The mold is sent to a large press which applies 20 tons of the pressure and heat almost up to 400 degrees Fahrenheit. This heat and pressure compact the carbon fiber and resin into the plastic and make it stronger. Once the mold is cooled down and handled, submerge into cold water for 5 to 8 minutes, which cools the disc ring completely, enabling them to pull out the cores that were inserted for the ventilation purpose. Once all the cores have been removed, remove the cover of the mold and extract the disc ring from the mold. Next is the machining process. The computer-guided machines then smooth out the rough areas and drill tiny ventilation holes at the brake disc. Next is the heat and chemical treatment. The disc ring is put into an oven which over 2 days, it gradually heats it up to 1800 degrees Fahrenheit. This causes the chemical change which transforms plastic into the carbon. Next, they pour the ceramic material, which is fine silicone powder, and load the crucible into the oven for over 24 hours. Next is the heat and chemical treatment. The disc ring is then put into a chamber where it receives a coat of protective paint. The paint shields the carbon in the disc from oxygen, which is critical because at high heat, oxygen burns carbon. The paint is cured in an oven, leaving behind a white residue. So next is the finishing process. The automated robot arm will sand and polish the entire surface of the brake disc for the final finishing process. Lastly is the inspection process. After the polishing is completed, a computer-guided machine thoroughly inspects the disc ring surface by taking the high-definition photographs to further examine the molecular and crystal structures to detect any defects. The computer will analyze the brake disc in the micron level of the details. So this is a technical drawing of the brake rotor, and all the dimensions are stated in the drawing. Simulation part. Total of 2 simulations that are carried out towards the brake rotors, which is the compression test and thermal distribution test on the brake rotors with the 3 different materials. First one is aluminum alloy, cast iron, and lastly is ceramic. So these are the results from the compression test with a force of 15 kN respectively. As a result, 3 of the materials shows that they can withstand the clamping force perfectly, and the maximum stress occurred on the brake disc is only slightly different, which ceramic materials had highest maximum stress. Next is the displacement plot from the compression test. From the results, we can see that the cast iron material displaced the most after compressions, and the ceramic material displaced the least among the others. This proves that the ceramic material is more ductile compared to the other materials. So lastly, this is the results from the thermal distribution test with a heat power of 6660 watts that generated from the frictions during the braking in a time period of 3 seconds. So, from the results plot, we can see that the ceramic material has better heat distributions and a higher heat resistance compared to the other materials.